Hello and welcome. Thanks for tuning in again. Today's lesson is going to be over function notation. So if you are not sure what function notation is, you've come to the right place. Basically what function notation is whenever we use the notation f of x. Now, that doesn't mean f times x. That means a function, f stands for a function, of x, okay? F of x is y, so I can replace f of x wherever y is. They mean the same thing, except for function notation is a little bit more specific about what it does. So if I had an equation, let's just say y equals 2x plus 1, if I change this to function notation, then I'm going to just change the y to an f of x, and everything else remains the same. So let's look at a couple of examples. Example 1 here, let's start with the function f of x is equal to negative x plus 7. And we're going to evaluate at f of 10. Alright, so we're going to find f of 10. So notice how the f is the same, but now I've replaced an x with a 10. That means I'm also going to do the same over here in my equation. Where x is, I'm now going to replace it with a 10. So instead of saying x is equal to 10, I'm writing it a different way. So now it's just solving that. So negative 10 plus 7 should give you negative 3. So my answer would be negative 3. For the same equation, let's say I wanted to find f of negative 7. So it's important this time that I do use my parentheses when I plug in. I'm going to be using the same equation as I was before. Oop, there's my lightsaber again. Okay, so same equation, negative x plus 7, and I leave the negative from the original equation. I'm plugging in negative 7. I add 7. Now I just do my order of operations. So I have negative 7 plus 7. These two negatives become positive. So I have 7 plus 7, which is 14. Example number 2. Here is one with an exponent. F of x is equal to x squared plus 2. Okay, this time we're going to start out plugging in f of negative 3. So again, I'm just replacing x with negative 3. So it's especially good that I use parentheses here, because if you try typing in just negative 3 squared into your calculator without using parentheses, it's going to say that it's negative 9, which is wrong, because you're actually supposed to take negative 3 and multiply negative 3, which is a positive. Okay, let's continue. So negative 3 times negative 3 is 9 plus 2, and this equals 11. Alright? And at any time, if I'm introducing an example and you don't want me to work it out, just pause it and then replay and see if you've done it right to check yourself. Okay, let's do another one. Same equation, so we're still going to be using x squared plus 2, but I am going to plug in an a. So in place of x, I'm putting an a, square it, and add 2. Now in this case, that's as far as I can go. I can't go any farther than that, because those are not like terms, so they do not combine. Okay, here's a third example. This time we have g of x is equal to 20 over x. This is the same as what we've just been doing. The only difference here is now x is in the denominator. So if you don't want to know the answer, pause right here. You can work it out on your own and then come back when you're ready. Alright, so if you work this problem, let's go ahead and go through this. So for g of 5, you should have gotten 20 over 5, which equals 4. So that means 20 divided by 5, which is 4. And for g of negative 1, I am going to plug in 20 over negative 1, which is equal to negative 20. Okay, now as we've been making these functions, or as we've been solving them, we have also been making ordered pairs because I have an x input and the answer that I get is the y, the output. So if I wanted to, this first one, I could actually make an ordered pair, and the ordered pair for the first one would be 5, 4. The ordered pair for the second one would be x was negative 1, y was negative 20, so my ordered pair would be negative 1, negative 20, okay? Okay, so now let's look at using function notation using a graph. So as you see here on the left, I have a graph. This is a function. If I run vertical line test, it passes. And over on the right, I have different values put in for x that I'm going to evaluate. Okay, so each one of these is giving me, in the parentheses, that is an x value. It's important to remember. So what they are asking for is what is the y. So basically each of these is kind of doing this. It's giving you x and it's asking you for the missing y in the ordered pair. Okay, so what you do is you go over to that value on the, that's not supposed to be lightsaber anymore, you go over to that value on the x-axis. So like the first one, I'm going to go to where x is 2, right here. Then I am going to see where it meets the graph. So right here, and the y value there, I would go over and look, the y value would be just 1. So right there, when x is 2, y is 1. Okay? Again, at any point, if you don't want to know the answer, you want to do them on your own, pause the video, and then replay to get your answers. Okay? Let's look at the next one. So f of negative 3. So this time, x is negative 3. So I go to the x-axis, I go to negative 3, and now I need to see where negative 3 meets my graph, which is right here. And that is 1, 2, 3, 4, 5 down. So that value of y is negative 5. F of 0. So I'm going to 0. And now I'm going to see where I meet the graph at x is 0, right here. And the y value there is 2. Now f of 6. So this time my x value is 6. So I'm going to go to 6. And now I need to see where does that meet my graph. So this time I have to go down 1. So here my y value would be negative 1. Now if it helps you, what you could do kind of as an aid for each of those, like the first one, f of 2, so we went to 2, you could actually put a point there, mark that ordered pair 2, 1, and then just know that your answer is going to be the y. Alright, so that's all I have for function notation. I hope that helped. Tune in next time for a new video, and we'll see you next time.